Hi, this lesson is dedicated to evaluating arithmetic series. The term itself refers to adding the sums of an arithmetic sequence. So when we talk about evaluating the series, that means we want to add the terms of a sequence together. That could be any sequence, doesn't matter what type. But we're going to talk about arithmetic sequences and series today. So there are two formulas that you're going to be able to use that. In this case, we're talking about a sub n representing an arithmetic sequence. The first formula is a lot easier. The first formula is right here. N is the number of terms divided by 2, and then you add the first term, and this is always going to refer to the last term in the particular series that you're trying to evaluate. It is a simpler formula, but you do need to know the first, the last term, and how many terms you're trying to add. But you don't always have this, so then you have the second formula, and the second formula is right there. It's more complicated, but it works in situations when this formula does not work. We would like to use this formula all the time, but it's not always easy. So sometimes we're going to have to use this formula. They will accomplish the same goal. For the same series, you're going to get the same answer. But this formula, you need to know the first term, the common difference, and the number of terms that you're adding, but you don't need to know the last term. But both formulas will require you to have the first term and the number of terms. So let's take a look at some examples. We're going to start with basic examples. So this is pretty simple. This is probably the easiest way you can do it. I want to remind you, arithmetic sequences are linear models, so anything that looks like mx plus b is going to match an arithmetic sequence. So we're trying to evaluate arithmetic series here. The way you're going to do it here, the first formula will work. We do need to find the first term, which is going to be a1. So you take 1, substitute it into the formula, and your first term is going to be 6. Then we're going to get the 19th term, because the last term will be associated with number 19. And so we're going to substitute 19 into that. 2 times 19 is 38, plus 4 is 42. So we have the first term and the last term. How many terms do we have? We start from 1, and we go all the way to 19. That's going to be a total of 19 terms. If you count all the numbers from 1 through 19, you will get a total of 19 terms. So then the sum here is going to be, we have 19 divided by 2, and here we're going to have 6 plus 42. Let's take a look at this formula again. We're doing the number of terms divided by 2 times the first term plus the last term. So we go back here, have 19 terms divided by 2, 6 plus 42. So when all this is calculated, it's going to end up giving us, there are various ways how you can compute that. The easiest thing to do here is add these two numbers together if you want to do it by hand. Or you can just plug it in the calculator, either way. But you're going to get 48 here times 19 divided by 2. And the answer here is going to be 456. And that's going to be our answer. So the second problem here, same thing. This is a linear function. We have k as our index here, which is okay. The first term is going to be when you substitute 1 into this. So it's 1 minus 3, that's negative 2. Our last term will be the 40th term. So that's when you substitute 40 here, it's going to be 1 minus 3 times 40. 3 times 40 is 120, minus 120 is negative 119. And then we are going to look at the number of terms. We're going to go from 1 to 40. That means we have 40 terms. So substitute everything into the formula. 40 over 2, the first term, plus the last term. This is the setup that we're going to have. So we're going to do the math here. We can do 40 divided by 2. And then multiply this by the sum. The sum here will be negative 121. And we are going to get negative 2,420. Okay, so these are very basic problems. You pretty much, well, I'm not going to say you have everything given to you, but you do have things that are easy to identify, and the first formula works. Now we're going to take a look at problems where it's not going to work. Take a look at example 3. Find the sum of the first 20 terms. So we have the number of terms. We can immediately recognize that n is 20. Of the series 2 plus 9 plus 16 plus 23 plus, and we don't know what the last term is. So we are not going to be able to use the first formula, so then we're going to have to use the second formula. Here is the formula again. This is the information we need. So we do need to know the number of terms. We already know that. We can identify the first term. That's easy. We do also need to find the value of the common difference. So with that, we are going to need to look at the two terms that are right next to each other. 2 plus 9. We can see that the common difference here will be 7. So the common difference is 7. And the first term obviously is 2. So we're going to substitute all this into the formula. So we're going to have n over 2. So 20 divided by 2. Bracket 2 times the first term, which is 2 also, plus 20 minus 1 times the common difference, which is 7. So again, we have n over 2, parentheses, 2 times the first term, plus the number of terms, 20 minus 1, plus, times 7. You can type it all into the calculator. And you are going to get the answer, 1,370. Okay. So, as you can see, it's not that complicated. We're going to take a look at example 4. Similar question. So we're going to identify all the same pieces of information. So we know that n is 40 terms. We know the first term is going to be positive 3. The common difference here will be negative 6. Be careful, it's negative because our terms are going down in value. So the formula will be 40 over 2, bracket, 2 times the first term, that's 3, plus 40 minus 1, multiplied by the common difference, which is negative 6. All that goes into the calculator, or you can do it by hand if you really want. It's entirely up to you. And we're going to get negative 2,160. All right. So that's that. Now we're getting into some advanced problems. Couple things that you need to be able to do. So example 5 says find the sum and you're given the sequence. Here's the challenge we have. We know what the first term is, we know what the last term is, so it looks like a very good candidate for the first formula with one problem. We don't know how many terms we have. You could use the second formula, but again, you don't know how many terms you have, so we're going to have to find the number of terms. For that, we're going to have to do the following. We're going to have to remember the formula for the nth term of an arithmetic sequence. And what we're going to do is we're going to take 41 and we're going to try to find n. So my nth term will be 41. My first term is 5 plus n minus 1, which we don't know. And we can find the common difference here pretty easily. It is 3 times 3. So this is an equation that we're going to have to solve. And once we solve it, we're going to have the value of n, and we're going to know how many terms that sequence has. It does take a little bit of effort. So various ways you can do it. I'm going to continue this here. It's going to be, well, actually, let me write this here. 41 equals 5. Let's distribute the 3 first. 3n minus 3. We're going to combine like terms here. 41 equals 5 minus 3 is 2 plus 3n. Subtract 2. So we're going to get 39 equals 3n. And n equals 13. That means we have 13 terms. So we have the first term, the last term, and the number of terms. We can use the formula now. 13 over 2. The first term is 5, plus the last term is 41. And we are going to be able to type it in the calculator and get the answer. And we're getting to 299. I do want to warn you about one thing here. It is very important that you understand that the value of n here has to come out to be a natural number, which means a positive whole number. You cannot get a decimal here, you cannot get a negative number. So if you are going to be solving this and you are going to get a number that is a decimal or negative, then you need to go back and check your work because something is wrong. You cannot possibly get a number that's going to be like that. It has to be a natural number. Okay? So anyway, the answer here is 299. The last problem doesn't really look that complicated. It looks like the couple of problems we did in the beginning, but there is one tiny catch that I hope you can see. We don't start at 1. We start at 3. So we go from 3 to 16. I'm going to tell you one common mistake that students make, because you need to determine the number of terms correctly. The number of terms here is not 13, it is actually 14. If you can count the numbers starting from 3 and going all the way up to 16, you are getting a total of 14 numbers. That means we have 14 terms. Okay? So, what we're going to need to do now is do it the same way that we did the previous problem, but we have to remember when we say the first term, we typically associate that with the value of n being 1 or the value of j, whatever. But we actually, I understand the first term is something that is going to start the series. So in this case, the first term is actually going to be when j equals 3, which is our lower limit of summation. Okay, so when we're going to set these up, we're going to do 14 over 2. We can use the first formula, it works fine here. Have 14 terms divided by 2. The first term is going to be when we substitute 3 into this. So 2 times 3 is 6, minus 3 is 3. And then we're going to substitute 16 in here. 2 times 16 is 32. Minus 3 is 29. Okay. And this is how it's going to work. And then we can do it on the calculator, or if you're so inclined, do it by hand. And this is going to give you 224. Okay. So this is different kind of situations you can have here, starting with some basic problems and giving you some ideas on how to solve some of the more advanced problems. If you have any other questions or want to have a video on another topic, please let me know in comments. Hope this helps.